myself Neha Shah from LG Institute of Engineering and Technology from the Department of Electronics and Communication Engineering. Today I am going to explain you about small sample t-test for difference of means from the subject of probability and statistics from the unit of applied statistics. In the last session I had explained you about small sample t-test for the single mean. But today I will explain you for the more than one means for the difference of means. So in this we will taking more than one mean. So for that first of all we will letting that x1, x2, x3 up to xn and y1, y2, y3, y4 up to yn are two independent samples of sizes n1 and n2 with mean of x bar and y bar and standard deviations are S1 and S2 from a normal population with means mu1 and mu2 and the same standard deviations. So for that, so if we are defining for this t equals to x bar minus y bar upon s under root 1 upon n1 plus 1 upon n2. In this, we will take in the value of s equals to under root of summation x minus x bar whole square plus summation y minus y bar whole square divided by n1 plus n2 minus 2. In this, we had assumed the degree of freedom equals to v equals to n1 plus n2 minus 2. Because as you know that if we are taking single mean, in the last session I had explained you as v number equals to n minus 1, right? So if we are taking only one mean, then its value equals to n minus 1. If I am taking two sample means, then its value will be n minus 1 plus n minus 1. So overall its answer equals to, suppose if we are differentiating these two means, then its value will be n1 minus 1 and n2 minus 1. So if we are adding these two things, then it will gives you the value equals to n1 plus n2 minus 2. So this is the particular degree of freedom for the difference of means. Now, if we are finding the value of x bar, as you know that the x bar means its mean value of x. And similarly, if we are finding the value of y bar will be representing as its mean value of the random variable y. So how we are finding the mean value? You know the equation of mean value of x and y. So what is the value of it? X bar equals to summation x divided by total number of samples n and the value of y bar equals to summation y upon n. So by using these two equations we can solve the we can find the value of mean values of two random variables x and y. Now we will putting these two values in this equation, so we will find out the value of s, and if we are putting the value of s in this equation, so we can find out the value of t, and from the t table we can find out the critical value of t. So by using these two particular values we can give some decision based on this t test. Now in this we can also write this same equation of t in the different form if the standard deviations are representing in the form of s1 and s2. So the value of t will be representing as x bar minus y bar upon s under root 1 upon n1 plus 1 upon n2. In this, the value of s will be representing as n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2. So we will finding the value of s from this equation. We will put in this value in the above equation. So we can find out the value of t for the two different standard deviations s1 and s2. Now if you want to find out the value of s1 means it's the standard deviation of random variable x, right? So it will be representing by under root of summation x minus x bar whole square divided by n1. Because as you know that the standard deviation is the under root of the variance. So you are taking under root of it, then it will gives you the standard deviation for the first random variable x. Similarly, we will finding the value of s2 as it will be used for the random variable y. So for that we will use the equation as under root of summation y minus y bar whole square divided by n2. So by using these two equations we can find the value of s1 and the value of s2. Now we will putting these two particular values in the above equation to find out the value of x it will put in the above equation to find out value of t. Then we will find in the critical value of t, and by comparison we can give some decision, right? Now in this, note that if we will taking the value of n1 equals to n2 equals to n, means if we will taking the sample size for the two random variables will be same and the samples are independent to each other, then what will be the equation? T will be representing as x bar minus y bar upon under root of s1 square plus s2 square upon n minus 1, because we have taken only one sample size for the both random variables. The value of v equals to, v will be representing as 2n minus 2. By using this equation we can find out degree of freedom. Next, if we are taking the value of n1 equals to n2, and if the pair of values of x and y are associated or correlated in same way, then the above formula cannot be used. Means if we are considering that these two things are independent to each other, then and then only we can use the first equation, and if they are not independent to each other, means they will be correlated with each other, then we cannot use the above equation. So we will use the next equation as t equals to d bar upon s upon under root n minus 1. In this we will taking the b number equals to n minus 1. In this the value of d bar equals to summation di upon n. And if we are finding the value of s, standard deviation s in this equation, so what will be the value of it? Its value equals to under root of summation di square upon n minus summation di upon n whole square. So by using this equation we can find out the value of s. If we put in this value in the equation of t, then we can find out the value of t. Now in this, if you want to find out confidence limits of it, then we can find out confidence limits for the 95% of level of significance. For it, the equation will be x bar minus y bar plus or minus t 0.05 in bracket 1 upon s under root 1 upon n1 plus 1 upon n2. And if we are taking for 99% of level of significance, then this equation will be representing as x bar minus y bar plus or minus t 0.01 1 upon s under root 1 upon n1 plus 1 upon n2. So if we are taking 99%, then we have to take t value at 0.01, and if we are taking 95%, then we have to take t value at 0.05. And if we are taking the minus value, then it will give you lower limit, and if we are taking plus value, then it will give you the upper limit. So from these two equations we can find out the confidence limit of it. Now if we are taking some example based on this, then the example is like this. The means of two random samples of size 9 and 7 are 196.42 and 198.82 respectively. The sum of squares of the deviation from the mean are 26.94 and 18.73 respectively. Can the sample be considered to have been drawn from the sample to be considered to have been drawn from the same population? It means we have to find that these two random variables will be drawn from the same population or not. So for that, if you can see that the number of sample size, then number of sample size are 9 and 7, which is less than 30. So we can say that this example can be solved by using small sample test. So for this particular example, we are using the t-test. So for that, which data are given to you? N1 is given to you as 9, N2 equals to 7. Then the next thing is mean are given to you for the first and second type of random variables. So we will be representing it as for first random variable x, it will be representing by x bar, and for the second, it will be representing by y bar. So the value of x bar equals to 196.42 and the value of y bar equals to 198.82. Now the next thing you have given is the difference of this value, difference of the mean from its random variable, means this one. So which data is given to you? Summation x minus x bar whole square, and the value of it equals to 26.94. Similarly, for the second, its value equals to 18.73. So we're writing like this: summation y minus y bar whole square equals to 18.73. Now you know the equation of s. What is the equation of s? S equals to under root of summation x minus x bar whole square plus summation y minus y bar whole square divided by n1 plus n2 minus 2. Now if we are putting this value, summation x minus x bar whole square, summation y minus y bar whole square, n1 n2 in this equation, and after solving it, its answer equals to 1.806. Now, with assuming something, then it will be considered as null hypothesis. It will be representing by h0, the value of h0. In this, we're assuming that the two means will be same. It means we're assuming that the value of mu1 equals to mu2. So we can say that the two means are same, or we can also say that there is no significant difference between two different means. Now, if we are defining the alternative hypothesis will be representing by h1, and it is complement of this null hypothesis. So, it will be representing as alternative hypothesis h1. In this, we will taking mu1 does not equals to mu2. It means it has not a particular value, so it will consider as two-tailed test. So, if we are representing this particular value as mu1 equals to mu2, so other than this, it will be considered as it is not equals to this. So it will give you two tails, right? So this particular example will solve by using two-tailed test. So in this, we'll using two-tailed test t table for finding the critical value of t. Now in this, the next step is level of significance. As the level of significance is not given to us, so we will take in level of significance alpha equals to 0.05. Next thing we have to find out is test statistic, and value of it equals to t equals to x bar minus y bar upon s under root 1 upon n1 plus 1 upon n2. Now if we are putting all this value in this equation, after solving it, answer of it equals to minus 2.6368. Now if we are taking mode of this t value, then its answer equals to mode of t equals to 2.6368. So this is final answer of mode t. Now we have to find out the critical value of t, and then we are comparing this particular value with critical value. Now, where we are finding the critical value? Critical value we will find at this level of significance 0.05 and at V number. So for that, first of all, we have to find out V number. So the next step is critical value. In this, we will first of all finding the V number. V number equals to N1 plus N2 minus 2. Because we had taken two different means, right? So for these two different means, its value will be N1 plus N2 minus 2. If we are putting the value of number of samples for the first, second random variable as 9 and 7, then the answer of 9 plus 7 minus 2 equals to 14. So we will taking at V number equals to 14 and at level of significance 0.05, from this t table we will finding its value. So first of all, we will taking at level of significance equals to 0.05 and V number at 14, its answer equals to 2.145, right? So this one is the critical value of it. So critical value of t equals to 2.145. So we'll writing as t 0.05 and v equals to 14. Its answer equals to 2.145. Now if we are comparing this particular value with mode of t, then we can say that the value of mode of t is greater than mode of t 0.05. So from this we can give the decision as there is greater than sign, so we can say that our assumption is wrong. It means the null hypothesis is rejected at 5% level of significance. So from this we can say that the samples are not drawn from the same population. So this way we can solve for more than one mean values, and this one is for particular small sample size, means the number of samples will be less than 30. In the next session, I will explain you based on this small sample test, but for the correlation coefficient. Means if there will be correlation in between two samples, then for that how the t-test will be different, it will be well understood by my next session. Thank you so much.